So in order to make sure that we get the right data on the SSD, we have to strike a balance between being responsive to changes in the application workload and to thrashing data between the disk and the SSD. And what we use is what we call a return on investment model, which is very similar to the return on investment models that businesses use when they decide to invest in a new technology or a new product. We calculate the cost of moving that data to the SSD, and we calculate how much I/O to the disk drives we're going to save in the near future by moving that data to the SSD, and we apply an ROI calculation against a threshold that the user can set to determine whether it's actually worth it to move that data to the SSD. So we gather historical information on performance, we project that information forward, and then we use that information to make our return on investment decisions for migration. It is a form of storage tiering, but different people apply different kinds of rules to perform their tiering. Some people use a cache-like algorithm where every time you access something on disk, that data is moved to the solid-state disk. That is something that we find causes a lot of thrashing in the data, a lot of unnecessary data movement. There are some implementations of storage tiering where you collect data all day on the user's application, and then you migrate the data that was hot the previous day to the solid-state disk to be ready for the next day. And that works okay if your application is the same from day to day, but a lot of businesses run different applications during the day and at night, and that form of storage tiering is extremely unresponsive to changes in workload. So we wanted to come up with a way to implement the tiering that was at the same time responsive to workload changes and workload shifts, and also did not thrash the solid-state disk and cause extra work, which actually is harmful to performance. We don't use the same rules to implement migration of data to the solid-state disk that the controller uses to implement migration of data, for instance, to a cache, because migration of data to the controller cache is in general free. You had to move that data through the controller memory anyway to get it to the host, whereas migration to the solid-state disk has a cost associated with it because you have to read that data from the disk and write it out to the solid-state disk, which uses controller resources in the area of computes and bandwidth. So again, because there's a cost involved, we use a return on investment metric to determine whether you're going to recoup that cost. Count IOs to the data, but we count those IOs for fixed periods of time that we call epochs, and a section of data has to be hot relative to the data that's already on the SSD for several epochs in a row in order for us to decide to migrate it. Okay? And this allows us to eliminate one-shot, frequent, intense but one-shot data operations. It allows us to ignore sequential sweeps of the data, which cause a great amount of activity but do not get revisited, so the window for migration has already passed. And in general, it allows us to implement a successful ROI metric for moving the data.